All right, today we're going to wrap up our little exponents unit by talking about exponential functions, essentially what these would look like when they're graphed if you have a variable in the exponent position. So if we think back, we spent a lot of time on linear functions, and linear functions have a constant change in x and a constant change in y. So when we were looking at them before, we were able to tell if a function was linear or nonlinear, but today I'm also going to show you how to tell if it's exponential or not. So exponential functions are in this form: y equals a bx. Let me highlight that. Where the x is your variable is going to be in an exponent. That's what makes it an exponential function. Where a can't be 0 because that would wipe out this whole thing, and b cannot be 1 because then the exponent wouldn't matter. So a can't be 0, b can't be 1, but every other form of this equation would be what we call an exponential function. There will be a constant change in x and a constant ratio in y. So when we were doing, most of the time, a graph is pretty obvious, but most of the time we had tables. And we were making sure we had the same pattern for x and y to tell if they were linear, but y always had to be addition or subtraction. For exponential functions, instead of addition or subtraction, it's going to be multiplication. So that's what they mean by constant ratio. We'll be multiplying each time, or you can think of it as division, but instead of division, we're going to think of it as multiplying by a fraction. That way, b is our constant ratio. Here, a is always going to be our 0 term. So wherever x is 0, the other number is your a value. And then b is going to be whatever the ratio is. So if this was times b each time, that's where b would belong. Okay, so like for instance, these things could look like 2 times 3 to the x. These will be filled in, y and x will not. All right, so let's take a look at these tables, and we're going to try to figure out if they are linear or exponential. And if they are exponential, we're going to go ahead and write the function. So here, let's just look at the pattern. This is plus 2, plus 2, plus 2. And already, since it's adding 2, I know it's not exponential because it's not multiplication. And here we have adding 1 all the way across, so this would be linear. All right, for this table, we are subtracting 1, subtracting 1, subtracting 1, and adding 4 up here. So I would say this one is also linear. And let's go ahead and write the function. So I know that this would be y equals 2 over 1x, or just 2x, plus 2. That's my 0 term. This one would be y equals negative 1/4 x plus 0 in this case, so you don't have to put that. Okay, let's keep going. This time it looks like my pattern would be times 1/2 times 1/2. And since we're multiplying, this is going to be exponential. And then my 0 term in this case is 8. So I would have 8 in front, then whatever my ratio is. So this would be 1/2 to an exponent of x. That's how we would write these. And then last one, we have what looks to be times 2. And you should have a constant ratio in x. That's always something good to check. Both of these should have a constant ratio, like these are all plus 1 and all plus 1 again. So this one is exponential. And we would have y equals, my 0 term is 4. And then I'd have 2 to the x. All right, this says evaluate each function for the given value of x. That means we're going to plug in 3 for x. So I would have y equals negative 2 times 5 to the 3rd. And then we're just going to simplify. So negative 2 times 125 is negative 250. Okay, so you do have to follow your order of operations. You have to do exponents and then multiply second. Also, on your assignment today, you will be asked to graph one or two of these. A perfect way, or even I think there's some that are matching graphs. You don't have to draw the graph yourself, but you have to match them up. The best way to do that is to make a table where you're going to plug in 0 and 1. I think that's the easiest way to start. So if I plug in 0, I'm going to get my 0 term. Like this one, I would get -2. And if I plug in 1, I'm going to get -2 times 5, which is -10. And you could keep going if you need to narrow it down further than that, but usually these two are enough, or if you're graphing them on your own. So same process, except I would choose to plug in 0 and 1. Okay, so here, this time we have 1/2. You can write as a fraction or a decimal, but this is the same as 1/2. So we have 3 times 1/2, and this time they want us to plug in -2 for our exponent. And if you remember, I'm going to go ahead and change this to 1/2. When you have a negative exponent, you need to flip what's inside, so it'd be 3 times 2 squared, and now this is positive. 2 squared is 4. 3 times 4 is 12. Okay, or you could use the calculator to figure out what it is, but you should understand how negative exponents work. And then if I wanted to graph this, again, you could plug in a 0, which would give me 3. That was my 0 term, or my a value. And then if I plug in 1, I'd have 3 times 1/2 is 1.5, or 3/2, however you want to write it. But that's how I would go about graphing it if I needed to, and then you can just plot your points. A bacterial population, so I believe this is our last question for today, so we're going to do a word problem. A bacterial population y after x days can be represented by an exponential function whose graph passes through 0, 100 and 1, 200. Write a function that represents the population. So they already told us it's exponential, so we just need to figure out what my 0 term is, and in this case it'd be 100. That's where x is 0, and what my constant ratio is. So if I'm going from 100 to 200, that means I'm multiplying by 2. So my function would be y equals 100 times 2 to the x power. And it says find the population after 6 days. Well, I know x stands for days, so that means I'm going to plug in 6 for x. So I'll have y equals 100 times 2 to the 6th power. 2 to the 6th power, let's see, I think is 64. And then that would be 6,400. Let's see. Yep, 6,400. All right, that's the end of our notes for today. You are now welcome to move on to your assignment.